Today you're going to be learning how to use a dial caliper. Dial calipers are commonly used by both engineers and manufacturers to make very precise measurements. A dial caliper can be used to measure the outside diameter or object thickness using this part right here, the inside diameter or space width using this end here, step distance, which is hard to kind of see, it's kind of like from in here, and hole depth, which is right here. We're going to be using standard inch dial calipers, and they'll measure slightly more than something about 6 inches long. To measure the outside length, we take an object, okay, and we put the object in between these two caliper faces right here, put the object in here. For example, an outside diameter, okay, or thickness of an object. Here's an example here. We're measuring the thickness of this particular part. If we wanted to measure a hole or a slot width, we would use these two, and we would put this edge and this edge, all right, flush up against the insides of the hole or slot. So here's our example. We've got those two. Okay, I'm using the inside diameter of this particular hole. To measure step length, it's hard to see based on this diagram here. It's actually using this right here. It's the surface. We measure between the two caliper faces. For example, steps. So for example here, when we call it steps, it's as if you had a little guy who's going to walk up from this step, let's say to that step, a little Lego guy, and we're measuring how tall that particular step is right here. And to measure depth, okay, you can see here, this is how we measure depth. Let's say depth of some kind of hole or other object's recess. So for example, we're trying to measure how tall this is, how deep this slot is right here. That's going to measure the depth. So the blade, okay, is this particular part of the caliper right here. Normally that's where I put my hand. I'm right-handed, so I put the right hand on it. I usually put my right thumb, okay, on the slider here. Then I can kind of move the part back and forth. I can close it or I can go ahead and open it. The blade scale, if you look at a dial caliper, divides each inch into 10 increments. So this is the 0-inch mark. See, the big number is a 0. This is the 1-inch mark. This is the 2-inch mark. The big numbers are the inches. This is 3-inch mark. This is 4. Okay, and this one right here would be 0.1. This line right here would refer to 0.2, 0.3, etc. Okay, so each of those increments is 1/10 of an inch or 0.1 inches. As we open and close, okay, the jaws here, this pointer will spin around, okay, the dial rather, as we move the slider back and forth. The reference edge, okay, right here is the reference edge, keeps track of the big increments. For example, this one right here, we look at the line that we see. We can see a little bit of the number 8, but we can't see the line next to number 8. We can see the line next to number 7. So this would be 0 inches, 0 point, and since we can see the line to the right of 7, this would be 0.7 is what we would read, 0.7 inches. And then I'm going to show you in a moment how to use the pointer to read the rest of it. Okay. These are little teeth in here, okay, that allow it to move back and forth. So they call this the rack. There are a couple things. Any measuring device before you use it, you have to zero it. You have to calibrate it. Okay, so to calibrate a dial caliper, what we would do is we would loosen up this screw on the bottom. This is called the dial lock. And then you see, notice right here, when this is fully closed, our pointer should point to 0, but it's not. All right, it's not pointed at 0. So what we do is we open up this dial lock just a little bit, quarter turn or whatever, so that it's loose, and then we go ahead and spin. In this case, we would have to spin the dial this way a little bit to the right so that the 0 lines up with the pointer. And now that the 0 and the pointer line up, now we're ready to go ahead and tighten up the dial lock, and then it should be calibrated. Again, I'll show the cohort B folks how to do this when they're in class, hopefully tomorrow, if not next week. Every time that the pointer spins around the dial once, then the slider moves 1/10 of an inch. So every time this goes around, one all the way around, from 0 to 99, or 0 back to 0, really 100, then effectively this would end up moving. Let's say if we were to spin it one more, it would go from 0.7 to 0.8, for example. So one revolution of this pointer, okay, actually it's really the pointer that spins around. One revolution of the pointer, again, ends up being 1/10 of an inch, 0.1 inches, right? The dial itself is divided 100 times so that each of these marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, represents 0.001 inches. So as a result, we can measure with a caliper accurate to the tens, hundreds, thousandths of a place. So we can measure things to the thousandth of an inch when we use a dial caliper. That's why we would use a dial caliper rather than a ruler, because it's much more precise. Gives us much more accuracy, much more precision. To determine the outside diameter of this pipe, let's say, all right, first, how many inches? Well, here's the 0-inch mark. We can see the 1-inch mark. We can't see the 2-inch mark. So that's 1 inch, 1 point. And then we can see the number 5, but we can't see the line next to 5. So right here, we see the number here for 4. So that means we're going to go with 4/10. So we're going to go with 1.4. And then this looks like it's about 37 or so. So then 1.4, so 37. Sometimes it's possible to read where it is in between 37 and 38. I can't really see here. If I was to zoom in a little bit more, maybe I'd be able to estimate a little bit better. So again, this is how they're going to read it. The reference edge is between 1 inches and 2 inches, like we said, okay? What they're doing here is they're just measuring here. We got the 1 inch, and then we have the 0.4, so they're going to write it separately, 0.4 inches, okay? And they're going to write this as I said, 37. Okay, they're going to write as 0.037, and then they're going to go ahead and, all right, now they've zoomed in quite a bit. So now if this is around 37, so they're going to say it's maybe, we said 1.4, and I said 37, and it looks like it's maybe 1/10, so 1.4371, right? This last measurement is an estimate. I may say 1/10, you may say 2/10. Well, we're both probably somewhat close. Again, this is to the 10,000th of an inch, so it's okay that it's not going to be completely accurate to the 10,000th of an inch. But that's very, very precise. And then they write down each of the numbers separately and add them up. So that's how they get 1.4371 inches. So in this case, we're asked to read the block. Well, so we're at 1 inch, right? So 1 point. And then right here, we can see the line for the number 4. So it's going to be 1.4. Now, if you're reading in between 0 and 10, it's very important that we write it as a 2-digit number. So we don't want to write this as 1, 2. We have to write it as 0, 2, right? We need to write it as 2 digits. So 1.4, and then I'm going to write 0, 2, and then it looks like maybe 2/10. So 1.402 and 2/10. All right, again, that's our estimate. 1.4022. Okay.